For today's lesson, we will be solving problems involving arcs and chords. So we will be applying some of the theorems that we've learned from the previous videos. Let's have this example. If the radius of a circle is 25 cm, what is the length of a chord whose distance from the center is 7 cm? So what we're looking for here is the length of a chord from a given circle. Now we have some of the informations. First is that the radius is 25 cm. And then the other one is that the distance of the chord from the center is 7 centimeters. Now we will use this information and we will try to illustrate the given problem. So let's say we have here circle A. Now since what we're looking for is the measurement of the chord or the length of the chord, of course we need to draw a chord first. So let's say we have this chord BC. So again, we need to identify later on what is now the measurement or the length of chord BC. Next, so we know that the distance of the chord to the center is 7 centimeters. Now, to show that, what we will do is we will try to draw a segment from the center going to the chord. So let's say we have here segment AD, wherein this segment is coming from the center going to the chord. Now this one is 7 centimeters. This segment AD represents the distance of the chord to the given center. Now this segment AD is now perpendicular with chord BC. So later on, we will use that to solve for the chord. Next, another information that we know is that the radius of the given circle is 25 centimeters. Now, there are different ways on how you can write or draw the chord here, but the most accurate one is you have to draw the radius wherein one of its endpoints is also the endpoints of the given chord. So let's say from A going to B. So you have here segment AB, wherein this will serve as the radius of the given circle. So this one now measures 25 centimeters. Now after drawing the radius, as what you can see here, we already formed a triangle, wherein this one is actually a right triangle. Since again, the segment AD is perpendicular to the given chord, which is chord BC. Now, since there is a segment from the center going to the chord, and it is perpendicular to the given chord, that means this will also bisect the given chord. So, aside from this one, we can also say that segment BD is congruent to segment DC. Again, this happens because segment AD is perpendicular to segment BC. Now, to solve for segment BD, since this is just a right triangle and there are two sides given, we can use the Pythagorean theorem. So, our formula here will be AD squared plus BD squared. So, you add the squares of the legs and it will be equal to the square of the hypotenuse, which is segment AB. So all you have to do now is to substitute the values. So you have 7 squared plus BD squared equals AB squared, which is 25 squared. Next, so this is 49 plus BD squared equals 625. Then just transpose 49. So you have BD squared equals 625 minus 49, which is equal to 576. Now, to further solve for BD, what we will do is just get the square root of both sides. Therefore, BD now is equal to 24. Then just include the unit, which is centimeter. So since BD is already 24 centimeter, Since this is just congruent with DC, that means DC is also 24 centimeter. And like what I've said a while ago, to solve for BC, what we can do is, it's either you multiply BD by 2 or you add BD and DC. So what we can do here is just multiply BD by 2. So 2 times 24 centimeter. Therefore, measurement of BC is 48 centimeters. So now we can say that the length of the chord is 48 centimeters if its distance from the center is 7 centimeters and the radius measures 25 centimeters. So that's it for today. I hope you learned something and see you next time.